MLOps, or machine learning operations, is a set of practices that aims to streamline and automate the end-to-end machine learning lifecycle. It integrates machine learning development and deployment into the broader context of operations and software development. The primary goal is to enhance collaboration and communication between data scientists, machine learning engineers, and operations professionals. Key components of MLOps are 1. Collaboration and communication. MLOps emphasizes effective collaboration between cross-functional teams, such as data scientists, engineers, and operations. Communication is crucial to ensure that everyone involved understands the requirements, constraints, and goals of the machine learning project. 2. Version control. Just like in traditional software development, version control systems like GIT are used to manage and track changes to machine learning models, code, and data. Automation. MLOps leverages automation to streamline repetitive tasks such as model training, testing, and deployment, reducing manual errors and improving efficiency. Continuous integration and continuous deployment, CI/CD. CI/CD pipelines are employed to automate the testing and deployment of machine learning models, enabling faster and more reliable releases. Monitoring and logging. Robust monitoring and logging systems are implemented to track model performance, detect anomalies, and facilitate troubleshooting. Infrastructure as code, IAC. IAC principles are applied to manage and provision the necessary infrastructure for deploying and running machine learning models consistently. Model registry. A centralized model registry is used to store, version, and manage machine learning models, making it easier to reproduce and deploy specific model versions. Next, we will discuss the use cases of MLOps. 1. Predictive maintenance. MLOps helps deploy predictive maintenance models to anticipate equipment failures and schedule maintenance proactively. Fraud detection. Efficient deployment and monitoring of fraud detection models to identify suspicious activities in real time. Recommendation systems. MLOps facilitates the continuous improvement and deployment of recommendation systems in e-commerce, streaming, and other platforms. Natural language processing, NLP. Applications. MLOps supports the development and deployment of NLP models for tasks like sentiment analysis and language translation. So what are the differences between MLOps and DevOps? Data-centric nature. MLOps deals with the unique challenges of managing data and models, while DevOps focuses on code and application deployment. Experimentation and exploration. MLOps accommodates the iterative and experimental nature of machine learning, where models evolve over time with continuous learning. Model versioning. MLOps requires versioning not only for code but also for data and models, ensuring reproducibility and traceability. Specialized tools. MLOps employs tools specifically designed for managing machine learning workflows, such as MLflow and Kubeflow, alongside traditional DevOps tools. In essence, MLOps extends DevOps principles to address the nuances of machine learning development, deployment, and maintenance. Setting up MLOps involves implementing a systematic approach to managing the end-to-end machine learning lifecycle. Here's a step-by-step guide. Define objectives and requirements. Clearly define the objectives of your machine learning project and the specific requirements for deployment and monitoring. Establish cross-functional teams. Assemble cross-functional teams involving data scientists, machine learning engineers, software developers, and operations professionals to foster collaboration. 3. Version control. Implement a version control system such as Git to track changes to code, data, and models. Establish branching strategies for collaborative development. Data management. Set up a robust data pipeline to manage and pre-process data. Ensure data quality and establish procedures for versioning and tracking changes in datasets. Automation and CI/CD. Integrate automation into your workflow by setting up continuous integration and continuous deployment, CI/CD, pipelines. This ensures that changes are tested and deployed automatically. Infrastructure as code, IAC. Apply infrastructure as code principles using tools like Terraform, Ansible, or others. Define and manage the infrastructure needed for training and serving machine learning models. Model training and experiment tracking. Utilize platforms like MLflow or TensorBoard to track and log experiments during the model development phase. This helps in understanding model performance and selecting the best model. Model registry. Implement a model registry like MLflow's model registry to version, catalog, and manage trained models. This ensures traceability and reproducibility. Deployment. Choose a deployment strategy based on your infrastructure and requirements. Containerization tools like Docker and orchestration platforms like Kubernetes are commonly used for deploying models. Monitoring and logging. Set up monitoring tools such as Prometheus, Grafana to track model performance, detect anomalies, and log relevant information for debugging. Feedback loop. Establish a feedback loop to continuously improve models based on real-world performance. This involves monitoring, collecting feedback, and iterating on models as needed. Security and compliance. Implement security measures to protect data, models, and infrastructure. Ensure compliance with regulations relevant to your industry. Documentation. Maintain comprehensive documentation for the entire MLOps pipeline, including code, data, and model documentation. This aids in knowledge transfer and troubleshooting. Training and onboarding. Provide training for team members on MLOps practices and tools. Facilitate onboarding for new team members to ensure consistency in workflows. Continuous improvement. Regularly review and enhance your MLOps processes based on lessons learned, emerging technologies, and evolving project requirements. Remember that MLOps is an evolving field, and tools and best practices may change. Regularly assess and update your MLOps setup to stay current with industry advancements. MLOps is crucial in today's world for several reasons. Rapid technological advancements. The field of machine learning is evolving rapidly. MLOps provides a structured approach to managing the entire machine learning lifecycle, ensuring that organizations can adapt quickly to technological advancements and leverage the latest models and techniques. Increasing adoption of machine learning. Businesses across various industries are increasingly adopting machine learning to gain insights, automate processes, and enhance decision-making. MLOps streamlines the deployment and management of machine learning models at scale, supporting the growing demand for ML applications. Operational efficiency. MLOps automates and optimizes repetitive tasks in the machine learning workflow, reducing manual effort and minimizing errors. This operational efficiency is crucial for handling the complexity and scale of modern machine learning projects. Collaboration across teams. MLOps promotes collaboration between different teams involved in machine learning, including data scientists, engineers, and operations professionals. This collaborative approach is essential in today's interdisciplinary work environment. Scalability and deployment challenges. As machine learning models become more complex, handling their deployment and scaling becomes challenging. MLOps provides a framework for efficient model deployment, monitoring, and management in production environments. Ensuring model reliability. In real-world scenarios, the reliability of machine learning models is paramount. MLOps practices, such as continuous monitoring and automated testing, contribute to ensuring that models perform well over time and in changing environments. Regulatory compliance. Many industries face regulatory requirements concerning data privacy, security, and ethical AI practices. MLOps facilitates compliance by providing tools and processes for tracking and managing data, models, and infrastructure in a transparent and auditable manner. Cost optimization. MLOps helps optimize costs associated with machine learning by automating resource provisioning, scaling infrastructure as needed, and improving overall resource utilization. This is particularly important in cloud computing environments. Realizing business value, MLOps bridges the gap between machine learning development and delivering business value. It ensures that models are not only accurate, but also deployable, maintainable, and align with organizational goals, maximizing the impact of machine learning initiatives. Competitive advantage. Organizations that effectively implement MLOps gain a competitive advantage by deploying and updating machine learning models faster and more reliably. This agility in leveraging machine learning technology can lead to innovation and differentiation in the marketplace. In summary, MLOps is essential in today's world to navigate the complexities of modern machine learning, ensure operational efficiency, meet regulatory requirements, and ultimately deliver reliable and scalable machine learning applications that drive business success.